before we go into our next lesson, we're going to do a recap of lesson 4, which is literal equations. So literal equations, it's the same way if you're solving for a regular equation, but you have more than one variable. So in this situation, we have 2 examples, which is doing for practice. They're asking you to solve for each equation. So, and it's A for each of them. So I'm going to write, 10. So G equals A minus C plus B. We're solving for A. So for this one, we're going to add C on both sides. So I'm just going to move this up. So the G plus C equals A plus B. And then I'm subtracting B on both sides. And of course, I cannot combine these because they are like terms. So I'll have A equals G plus C minus D. That's my answer. And then for the other one, they want you to solve for A there. So Z equals BAM. You're going to divide the B and the M on both sides to have A by itself. So Z will equal A will equal, do that again. Actually, let me just do like that. A will equal Z over BM. So we have this and here. Right. So this is just a little review of translating from verbal to algebraic and the other way around. So we have this equation, or this expression, and we have to translate it. There's going to be different ways of you translating it. So I already put 2 different ways. There could be a lot of them. This one is the difference of a number and 4 is 15. That's one way. Another way you can write it is 4 less than a number results in 15. So like I said, you may have different ways based on what you've learned, as long as it's when someone reads it and they can translate it to exactly what this is, what we started off with, then you're on the right track. Now the next one. There are many ways. I chose this way. So it'd be negative 7 times the sum of a number and 5 gives 15. If you have another way of translating it, and if someone were to read it in order to get to this one, then you did good. Now, that was from algebraic to verbal. We're doing verbal to algebraic. So 1 less than the product of 4 and a number is 11. So we know 1 is the number 1, less than is the minus the product. Product means multiplication. So we got 4 and a number. Do we know that number? No. So we're going to have it n. Is translates to equal, and we have 11. So this is something we were talking about, the less than. Anytime you see less than, you have to switch. Because 1 less than something. That means you already have something that was existing there, and you're taking 1 less of it. So that it would be that product 4 and that's product, minus 1, because you're taking 1 away from something, so 1 less than whatever you had, and then is 11. So be careful with that. And then the other one is the product. Product we was multiplying of 8 and a difference. So we got 8 and the difference. Difference, subtract of n and 3. So when you see that and, you might right away put plus, but you have to read the whole thing. Because that and is just saying the product. Product is going to be 2 or more numbers multiplied together. So we have 1 of these numbers, and then we have this group. So then that means the product of 8 and the difference of n minus 3. move on. Actually, I should make this bigger. So before we go into our next lesson, we're going to read, actually I'm going to read and you're going to be listening to our story time. What am I doing? Let me get this to select. And let me go back to expanding that. Alright, so here's the story. When I was about your age, I was given a lot of responsibility. My mother used to arrive home from work later than me, so I was supposed to have snack and then begin my homework. I was not supposed to watch TV, call friends, or leave the house. One day, I finished my homework early, and I knew my mother wouldn't be home for a few hours. I decided to go over to a friend's house nearby. Although I knew I wasn't allowed to, I rode my bike to her house. About a half hour later, the doorbell rings. My mother was at the door. She was driving by on her way home and recognized my bicycle in the driveway. She ordered me home immediately, and I knew I was in trouble. I was grounded for a few weeks, which meant I wasn't allowed to visit any friends, talk on the phone, or watch TV. I felt like I was in jail. After a few weeks, my punishment was over, and I was released from jail, and I was absolutely, positively happy. So this is going to lead us to our next lesson, and you'll find out why I've bolded and quoted released from jail and absolutely, positively happy. So our lesson that we're doing is absolute value equation. And the objective is, how do we solve absolute value equation? So absolute value is a distance from zero on a number line. So your starting point is 0, and it's either you go from 2, in this example 2, or you go to -2. So the question below is, what two values could we replace x in this equation? You know, this is a symbol that you see for absolute value, have two vertical lines, and then whatever number or variable inside. So what's two numbers? So we're looking for something that will equal 2. If you said 2 as one of the answer, you're correct. There's another one, -2. So when we solve an absolute value equation, we need to consider two cases. The expression inside the absolute value symbol is positive, coming from the right side of the middle number, and the expression inside the absolute value is negative, coming from the left side, the left of the middle number. So when you deal with absolute value equations, always remember that there's going to be two possible answers. Not one, two possible answers. Because whatever is inside the absolute value symbol, if it's negative, it's going to turn out positive. If it's positive, it's going to turn out positive. So going back to that story where we're talking about release from jail and absolutely positively happy, think of the numbers as being in jail. You have a number inside that's in jail. If it's a negative number, if it's positive, maybe it knows that, okay, it didn't do anything, it's not guilty, they'll get out, and everything will be okay. But if let's say a negative number, it just wants to be free, it's done its time, and it's going to be released, early release. Once it's out, it's going to be happy. So happy, positive. So remember it that way. So now let's dissect this absolute value equation. Actually, no, do that first. All right, so we have x minus 2 in the absolute value symbol, and then we have 7 equals 7. So this number, just the number itself, not what sign is in front of it, tells you the middle of the number line. And then the 7 that's outside, the other side of the equation, tells you the distance away from the middle number. So if I were to put this in here, I would have actually I'm going to write this 10. So my middle number is 2, and then the 7 7 tells me my distance. So we have 1, 2, 3, 4, 5, 6, 7 in this direction. And also you have to go the other direction. 1, 2, 3, 4, 5, 6, 7. 7 in that direction. So you go to the left of the middle number and you go to the right of the middle number. So that's a way to interpret that. Now let's say you have this, a plus sign. You may think, oh, 2 is the middle number, but be careful. We're going to get to that, but this can be written as, push it here, the same as x minus negative 2 equals 7. So then if you were to do that on the number line, actually, before we even do it on the number line, what would be the middle number? It wouldn't be 2. It would be negative 2. And the distance is 7. So for this one, actually, before I even do that, we do the number line. My number line is not here. So we would have it, if I did have the number line, I'm going to put in another color. I thought I had it at the bottom, but I didn't. So this one would be my middle number, and I'm doing 7. 1, 2, 3, 4, 5, 6, 7 in this direction. And then I'll do 1, 2, 3, 4, 5, 6, 7. So it'll be negative 9 and negative 9 and positive 5. So when I plug it into this in the absolute value equation, it will work. Negative 9 plus 2, I got a negative 7, it turns to 7. Because any number inside that's negative needs to be released to be happy, released out of jail. And then we have 5 plus 2, 7 is positive, it just will be positive. So notice how on the number line, it all works out. So, with that being said, the formula for the absolute value is x minus the middle number equals the distance. And in symbol notation form, it's x minus m equals d. So notice how when, I'm going to go back to that. Notice how when we started off, there was a minus. So this is the actual formula, the x minus m. But notice how this is a plus. So anytime you see a plus, you know that that formula has to have a minus in it. So it's going to turn to minus, and then you will make the number negative. Because the negative times a negative gives you a positive. So this is the same as this. So that means this will represent the middle number, and you have your distance. Sounds confusing a little bit, maybe not, but we're going to go through a few examples, and then we're going to do another way of solving absolute value equation. So for this one, we have the same thing. We have f plus 5 equals 17. It's a plus. We know that we can write it like this. You keep, you change the sign. If you want it to, only time if it's a positive, you keep, change the sign to positive, and then you do the opposite of that number. So then that will give you this form. So then your middle number will be negative 5, your distance will be 17, and then when you plot it, so your middle number is negative 5, and then I'm just going to put show an arc, and I have positive 17, and I have negative 17 in this direction. So when you add that, when you add that, you should get 12 on this side. And then when you, remember, you're subtracting. So negative 5 minus negative 17, that'll give you negative 22. So then your answers will be x, negative 22, and 12. Don't put parentheses, because remember, parentheses, that means you're doing coordinates, and these are not coordinates. These are just numbers that are part of that set that will be the best numbers for the correct numbers for x. So this represents a set. When the bracket. All right, let's go on to the next one. This has a minus, so the middle number is that positive, so it's 1. Oops, that's supposed to be 1, not -1. And then the distance, it shows -3. What can we conclude about this type of equation? Just look at it. Remember when I said that anything inside the absolute value symbol, if it's negative, it has to be positive, and if it's positive, it has to be positive? What's going on here? So what we can conclude is that there's no solution because the distance cannot be negative. Distance cannot be negative, especially when you're dealing with absolute value. Because anytime you have something in the absolute value, whether positive or negative, it has to come out positive. In this case, it will never, whatever you have here will never equal what's out here. So there's no solution. And if you come across something like that, you can write no solution, or you can write it in the notation as S with a 0 and a slash in between it, through it. So you can write it like that, no solution. All right, let's do a word problem dealing with this. It says that an ice cream should be stored at 5 degrees Fahrenheit with an allowance for 5 degrees. Write and solve an equation to find the maximum and minimum temperatures at which the ice cream should be stored. So, we need to know what our distance and our middle number is. So, for this one, this is our middle number because that's our starting point. That's what it should be stored at. The allowance tells you you can have this, it could be a little bit less, maybe a little less than 5 or a little more than 5. So the allowance is, that'll be a distance. So it could be more than 5 degrees or less than 5. So then we have our formula, x minus m equals d in absolute value. And then we do the number line. 5 is our middle, and then we go 5 to the left, 5 to the right. And if you subtract 5 minus 5 gives you 0, and 5 plus 5 gives you 10 as your max. And then, of course, you would write it in this form. So that tells you the maximum would be 0, 10, and the minimum would be 0. So again, how to write an absolute value equation, find the middle number between the origin of the graph, and then use the equation to find your range, your top and bottom. All right. So we're just going to do a few examples. Here we have to write an equation involving the absolute value for the following graph. So we need to find the middle number, and we need to know the distance between that. So if you can visually do this by counting and getting from the left and right and have them meet in the middle, or you could do the average. So you have 17 plus 27 over 2. Over 2, that's divided by 2 numbers. And then you can get 44. You get 44, and then your middle number, I'm going to put M for that, is going to be 22. So then you have 1, 2, 3, 4, 5. So that's 5. So that should be 5 also. So now you know that your middle number is 5, your distance, your middle number is 22, your distance is 5. So when you write it in the formula, it'll be x minus 22 equals 5. And don't forget the absolute value symbol. So you could do it that way, like I said. You could add the 2 numbers and average it out, find the middle number, the average, or you could count from the 2 points and see where they meet. But this would be the quickest way, but whichever helps you. But if it gives you the right answer, then you're fine. All right, the same thing with this one. We have -2, and then we have 4, so we're going to add those 2 and divide by 2. That'll give me 2 over 2. So that means my middle number is 1, and my distance is 1, 2, 3. So it's 3. So that means I'm going to write it in the equation, which will give me x minus 1 equals 3. Absolute value of x minus 1 equals 3. All right, now we have to solve the equation and then graph the solution set. So we're doing two things. So the first thing, I noticed that that's plus. So that means I could write it as n minus negative 7. Remember, you change the symbol, and then you do the opposite. So now my middle number, I should write that my middle number is negative 7, and my distance is 5. So I'm going to start at negative 7, and that means I'm going 5 to the left. Oh, I don't know, where am I going with that arrow? Let's do that again. 5 to the left and 5 to the right. So positive 5 and negative 5. You add this 2, gives you 12. You subtract, remember, 7 minus negative 5, that gives you negative 12. Sorry. Did I get that right? No. Yeah, that's right. Hold on. 7 minus 5, sorry, negative 2. There's no negative 7 in there. My bad. So let me undo that. To be negative 2. Positive 2. Positive 2. So 7 minus 5, 2. And your results, negative 2. Oh, you know what? I goofed. It's supposed to be negative 7. I messed up. Sorry about that. I just had the positive 7. Should have realized that. So that was right the first time. This was negative 12. So you got to be careful with that. And then this one is negative 2. It can happen to the best of us. So negative 12, negative 2. All right, let's go on to the next one. So before we even do anything, notice that we have 3z minus 3. And we need to get it to the x minus m equals d. So that variable, that x or whatever variable, has to be by itself. So we can divide this. So I'm going to divide 3, since it's 3 can go into each of them. That's the GCF, the greatest common factor. So that will turn into z, don't forget the absolute value symbol, minus 1 equals 3. So now we have our middle number, which is 1, and our distance, which is 3. So we put our m, 1. So this will be negative 3, and then this will be positive 3. So this will give us 4, and then it's 1. It'll be negative 3 minus 1. No. 1, yeah, let's make sure I got that. Negative 2. And then we got our answer. Negative 3, and we have 1 to negative 2. So our two solutions, this shouldn't be in the, I forgot to tell you that the answer, yes, it was in parentheses. That's not correct. It should be like this, with this squiggly line. Because that's telling you that's an x and y value, which is not correct. Alright, for this one, I'm not even going to do anything because I notice my distance is negative 6. So, in this case, there's no solution. When you see that your distance is negative, don't even bother doing any work. Just write no solution or just put the symbol no solution. And for this one, there's a plus. So we can turn that into, so we got keep, we change the sign, and then we do the opposite of the number. So then our m, our middle number is negative 4, and our distance is 2. So we got negative 4 here. And we can do positive 2, and then we do negative 2. So we got negative 4 plus 2 gives us negative 2. And then negative 4 plus negative 2 gives us negative 6. And then we should have it written as negative 6, negative 2. This is not the right symbol. It should be this one. So I'm going to cover this one up. That way you know that's the answer. Okay. So now we have to write an absolute value equation based on the following graphs. So notice how we use the equation in order to graph what was given. Now we have to do the opposite. So for this one, we try to find the middle number. You could hop on both sides, going to the same direction. Go in opposite direction until they meet, or you just do the average. So you have negative 9 plus 3 over 2 is negative 6 over 2. So your middle number is going to be negative 3, and your distance 1, 2, 3, 4, 5, 6 is 6. Select negative 3 and 6. So now to write the equation, to write the equation, we'll write that out. So we have whatever variable, we use x. And our middle number says it's negative 3. So again, we plug it into it. And our distance is 6. But we can also write it as x plus 3, because the negative times the negative gives us a positive, and that's our answer, our equation. Okay, same thing with this one. We have 9 and plus negative 3 divided by 2, so it gives us negative 12 divided by 2. Our middle number is going to be negative 6. And then 1, 2, 3, we got the distance as 3. And then we write our equation. So there'll be, I'll put x, and our middle number is negative 6. Remember, I'm using that formula. I'll just write it out. And our distance is 3, and that can be written as x plus 6 equals 3. All right, move on to the next one. Same thing, negative 1 plus 5 over 2 get us our middle number. So this would be a 4 over 2, and this would be 2. 2 is our middle number. Our distance is 3. So let's unveil that. And then we write it our absolute value equation. So it's x minus m equals d. And then our x minus our middle number is 2. So we leave it as that. And then our distance is 3. Okay.
All right, so I'm going to stop here. This is part 1 of absolute value equation. I will do the second part, which will start with working with absolute value equations when you have to isolate it.